Okay, good evening. My name is Faith, and I'm going to do my written exam module 1. Okay, we're going to start with number 1. We use the divisibility test of numbers 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and it is to find out how we work each problem. Okay, so this will show that 2 is divisible by these numbers if it says yes or no. Okay, so we're going to start with number 2. Okay, to find out if it's divisible by 2, it has to end in an even number. Okay, so 684, yes it does because 4 is even. 4 is even, so yes it is divisible by 2. 1, no, because it's an odd number, not even. 0 is even because it is divisible by 2, and 0 is divisible. And then yes, because it is divisible by 2. Okay, for 3, to find if it's divisible by 3, you have to add up all the numbers that are in the given number problem, and if they evenly divide by 3, then yes, they are divisible by 3. So, like for example, we'll do the first one, 684. 6 plus 8 plus 4 equals 18. So 18 divided by 3 is 6. So yes, it is divisible by 6 or by 3. My bad. Okay, and then we'll do 2064. 2 plus 0 plus 6 plus 4 equals 12. 12 divided by 3 equals 4. Yes, it's divisible by 3. Okay, we'll do one that's not. Okay, 2 plus 6 plus 7 plus 6 plus 7 plus 4 plus 0 equals 32. 32 is not divisible by 3, so no. So you just put no. Okay, 4. 4, if the last two numbers are divisible by 4, the whole number is divisible by 4. Okay, so out of 684, we'll take 84. 84 divided by 4 equals 4. So yes, it is divisible by 4. Okay, 2064, you'll take 64. 64 divided by 4 equals 31. So yes, it is divisible. Okay, here's one that's no. You'll take 51 because it's the last two digits. 51 divided by 4 does not work. So no, it does not. Okay, so then we're going to go to 5. If the last number ends in a 5 or 0, the number is divisible by 5. Okay. 684, the last number is 4. So no, it's not a 0 or a 5. Okay. As you can see, this is a 4, this is a 1, so no, they're not. This is a 0, so yes, it is divisible. This is a 0, yes, it's divisible. This is the 8, so no. 6. The number must be divisible by 2 and 3, not 1, but both. If it is, then yes, it is divisible by 6. Okay, 684 is divisible by 2 and 3. 2064 is divisible by 2 and 3. 51,051 is divisible by 3 and but not 2. So that one doesn't work. Okay, 644,000 and 490 is divisible by 2 and 3. 2,676,000 or million is divisible by 2 but not 3, and so on. Okay, so now we're going to go to sevens. Okay, you go 684. Well, you'll take the 4 and you'll multiply it by 2. Okay, so then it's 68 minus 8, which is 60. 60 is not divisible by 7, so no. So 2064. 2064, you'll take off the 4, multiply it by 2. 206 minus 8 is 198. Okay, so then you go 198, you'll take the 8, multiply it by 2, so you'll get 19 minus 16, which is 3. No, 3 is not divisible by 7. Okay, so we'll go, this will be the, we'll do this one. No, we'll go to this one. Okay, 644,490. We'll skip the 0, so we'll just start with 64,449. Okay, you'll take off the 9, multiply it by 2. So then we get 6,440 minus 18. So we get 6,426. Okay, so then we'll take off the 6, multiply it by 2, and we'll get 242 minus 12, which is 230. 230, okay, hold on. Okay, so then we'll skip the 0 with 230. So then we'll skip the 0 with 23, and 23 is not divisible by 7. So no, that one doesn't work. Okay, and then we do the exact same thing for this one, and the exact same thing for this one. Okay. Then for 8, if the last three numbers are divisible by 8. Okay. This is the last number pretty much. Okay, 680, no, the last three numbers. 684. 684 divided by 8 doesn't work, so no. 2064, so we'll just do 064 divided by 8, yes, so that one works. Okay, so then we'll take 051. 051 divided by 8 does not work, so no. Okay, so we'll take 490. 490 divided by 8 doesn't work. 740 divided by 8 doesn't work. 528 divided by 8 is 66, so yes, it works. Okay, for nines, we add them up and then divide them by 9. So you add up each number. So 6 plus 8 plus 4 is 18. 18 divided by 9 is 2, so yes, it works. So you just add up every number, then divide it by 9 and see if it works. For tens, if it doesn't end in a 0, it will not work. Okay, so 684. No, it doesn't end in a 0. Does that one end in a 0? No. Does this one end in a 0? No. This one does end in a 0, so yes, it is divisible by 10. This one ends in a 0, so yes, it's divisible by 10. This one ends in an 8, so no, it's not. It doesn't do. It's not divisible by 10. Okay, for 11, you're alternating the sum. So like you plus minus plus minus plus minus. Okay, so 684 is the number. So we're positive 6, negative 8, positive 4. Well, that equals 2. 2 divided by 11 doesn't work. So we have 2064. So it's plus 2 minus 0 plus 6 minus 4 equals 12, which is divided by 11, so it doesn't work. Okay, this one, we'll try this one because yes, it works. Okay, plus 5 minus 1, 0 minus 5 plus 1. Okay, is alternating the sum to 0 and it's divisible by 11. Okay, so that's how you do that. Okay, well now we're going to start with number 2, casting out 9. Okay, and so the first thing we do is we add up each number. So 4 plus 1 plus 6 equals 11. Well, you don't want 2, so you'll just add 1 plus 1 for 11 equals 2. 7,490, you will add it up and it comes to 20. Well, 20 you'll go 2 plus 0, which equals 2. 69,844, you added that up, that comes to 31. So 3 plus 1 equals 4. So that becomes to 8. Okay, so then you do the number that was given as the final answer. You add it up, it comes to 20. Well, 2 plus 0 equals 2. So that shows, because it's 8 and 2, they're not the same number, that casting out 9 shows an error. Error. The given answer has a remainder 2. The casting out 9 has a remainder of 8. The correct answer is 77,750, which is shown below. Okay, so now since we worked out that, we're going to do casting out 9s to number 2. Okay, so you get 8,550. Okay, so when you work that out, it comes to 18. So then you'll split 18 to 8 plus 1 equals 9. So the next one's 22. 2 plus 2 equals 4. Okay, the next one comes out to 14. 1 plus 4 equals 5. 17. 7 plus 1 equals 8. That comes to a total of 26. Okay, so then you do the answer that they gave us. 24. 2 plus 4 equals 6. Well, then that also shows that a casting out 9 shows an error, because the given answer has a remainder of 6, and the casting out 9 has a remainder of 26. The correct answer is 23,992, and it shows how we got that. Okay, casting out 9s for C. This is with subtraction. Okay, so you add it up the exact same way, and you get 26. 2 plus 6 equals 8. 20. 2 plus 0 equals 2. Well, then you subtract 8 minus 6, or 8 minus 2, which is 6. Okay, so then you do the same way with the correct answer, 32. And 30 minus 2 equals 1. Okay, so then it shows that casting out 9 shows an error. The given answer has a remainder of 1. The casting out 9 has a remainder of 6. Okay, the correct answer is 74,688. The next one, we are using multiplication. Okay, so 337, we get 13. 1 plus 3 equals 4. Okay, so then we get this one is 8. Well, 8 times 4 is 32. Do the exact same thing as 24. 2 plus 4 equals 6. Casting out 9 shows an error. The given answer has a remainder of 6. The casting out 9 has a remainder of 32. The correct answer is 208,940. Okay, for number 3, we're measuring out rods. Okay, for number 3A, it says measure 9 rods. out of these. So with this one, you got to measure 9. Well, you're finding the factors of 9, which is 1, 3, and 9. 1 times 9, 3 times 3, 9 times 1. 3B measures 6 rods. Well, you're using the factors of 6. So 1, 2, 3, and 6. And how we got the factors are right here. The greatest common divisor of 9 and 6, as shown, you get 9 and you write out the same ones that you got. And the greatest is 3. For 3D, you're using the 10 rods and the 8 rod end to end to form an 18 train. You're adding them together in the factors of 18. So it's 1, 2, 3, 6, 9, 18. How we got those? Okay, you're adding 7 and a 5 rod together to make 12. So you do the factors of 12. 1, 2, 3, 4, 6, and 12. Okay, then the last question, it says, briefly describe how you might use these color rods to demonstrate the notation of greatest common divisor, greatest common, or GCD, to children. Okay, we might have colored these rods to demonstrate the notion of GCD to children. The greatest common divisor of two numbers R and S is the length of the longest train or rod that will measure both the R train and the S train. So it was finding the greatest common divisor of both and putting them together and see which one had the biggest number, which we found was 3. Okay, for 4, we're finding the LCM. We're using the LCM method to find. So we're using the LCM method, factoring method. We're going to find the least common multiples of 3 numbers using prime numbers to find power. So you have 48, 25, and 65. We're using the smallest prime that divides with the first number. 48 is the smallest prime, which is 2. If another number will divide with some prime, work it out. But if they don't, bring them down. Then continue the process. When you can't divide anymore, put the numbers of the far left and very bottom, all primes together like numbers, receive an exponent, and different numbers are separate by a multiplication sign. So as we do this, we work it out like this, and you finally get 2 to the 4th, which is right here, 3 and 1, 5 and 2, which is 2 5s, and then 13. You're doing the same thing as before. The answer is, with the LCM, you get 40, 12, 44, and 363. We got 2, which is actually 3, so 2 to the 3rd, 3 to the 1, 5 to the 1, and 11 to the 2nd power. Ones are included. The LCM of this one, the answer is 2 to the 4th, because you got 4 2s over here, 3 to the 1, 5 to the 3, 7 to the 1, and 11 to the 1. For 5, in a machine gear with a 48, okay, so the first step is to find the least common multiple of 48 and 84. Find the product of the prime powers and the prime power factorization of 48 and 84 that have a large exponent. Okay, so we got to do the prime factorization, which is like the tree of 84 and 48. So when you come out, you get 2 to the 4th times 3. The 84 is 2 to the 2nd times 3 times 7. So then you would do this. So you get 2 to the 4th times 3 times 7, which you just add this together like this. Okay, equals 336. Well, 336 divided by 48 equals 7. So therefore, the small gear has to make 7 more revolutions before A and B are again in the same position. Okay, 6. Making a magic square. Okay, so they're giving us -7, -6, -5, -4, -3, -2, -1, 0, and 1. Okay, the first step is to add up all the integers, which is all the ones they've given us, which equals -27. We know that the sum in each row is the same. 3 times this sum is the same as the total sum of all the integers. So 3x, which is, there's 3 in each row and column, equals -27. So you got to get rid of the number by the x so you can get the value of x. So you divide each side by 3 and you get x equals -9. So that means that's the metric sum. It means that each row and column have to equal to be -9. After using trial and error to figure out where to place the numbers, like just putting in, guessing, adding them up to see what they come out to, we know that each sum of each row has to equal -9, and each column of sum has to equal -9, and each diagonal has to equal -9. So like 0 plus -3 plus -6 equals -9. -4, -3, -2 equals -9. This way equals -9, this way, this way, this way, this way, this way. And the correct answer is 0, -5, -4, -7, -3, or 1, -2, -1, -6. And that's how we find it. Okay, that's all I have for my written exam module 1. I hope you have understood what I'm trying to explain for these answers. Thank you.